All right, let's go. So, structure your GraphQL apps. What a title, huh? It's assertive, it doesn't really say anything. What's the alternative here? Of course, I'm going to structure my apps. There's nothing else to do. It's clickbaity, but it did get me a chance to talk here, so I guess that works. So, yeah, don't hate the player. Nice. All right, so this is really the title I wanted to go for initially, because this is really what the presentation is about. So this is just me talking about a proposal on how you can structure your GraphQL apps. Whether you want to do it or not, that's really up to you. I'm not a preacher here, so whatever. A bit of information about me to start with. My name is Christian. I'm originally from Aarhus in Denmark, currently living in London. I work at Meta, and then I'm the maintainer of the GraphQL Flutter packages. I'm also the creator of the GraphQL CodeGen library. And as will become very apparent from this presentation, I'm a top-tier presentation slide designer. So I'll go through these 4 points during the presentation. First, I'm going to try and give a quick introduction to GraphQL. I know a lot of you already know about it, so it will be quite quick. Then a quick comparison between GraphQL and REST, and then I'm going to go into the main part, which is proposing a way to structure your GraphQL apps. And finally, I want to talk just a bit about the future of the GraphQL CodeGen framework. Sounds good?
Sure.
Amazing, that's good. All right, during the presentation, I'm going to talk a bit about scalability of products. And I think, at least for this presentation, we can look at scalability for at least 3 different axes, right? So we of course have the performance axis, which we all know. Like, how can we build the apps that are performant and scales to the amount of users that we want to serve? Then I think it makes sense to look at the developer experience. How can we make sure that our products are able to scale to new developers coming into the team? How can we make sure that they can easily onboard and start being productive? And finally, the maintainability axis, which is very, very related to the developer experience axis. Here, we are focusing on how can we write apps or products which are easily to maintain, which are easy to read, and easy to work with for other developers as well. So, quick introduction to GraphQL. So it's a query language. From a lot, it's maybe seen for a lot of people as a replacement to REST. Some others not. And it allows us on the server side to specify a schema of our data, like this. And like this example here, where we are first exposing a new root query field, which allows us to fetch a user from our data, from our backend. And then we are defining the user itself with an ID and a name and a set of children. So you can see you can define your types and in a recursive manner here. The user itself has a reference to other users, for instance. Then on the client side, you can perform a query against your server. And in this example here, we are going to fetch a user by a given ID. We're going to extract the name field, and then we're going to fetch all the immediate children of that user and their names as well. So you can see how you in GraphQL are able to recurse down the types, right? Then the data might look something like this. In this case, we are fetching out Bob, and Bob has 2 wonderful named children called Bob Jr. and Kurt. And yeah, that's sort of the whole setup here. So a quick overview. Server side, you have the schema, then you have some sort of network protocol in between. And on the client side, you will have the executable GraphQL, like queries, mutations, descriptions, so on. And then this allows us to communicate data. And I think that's a very good starting point for an API, that we are actually able to communicate data in between our server and our client. But something that GraphQL also allows us to is communicate types between the server and the client, right? So a usual setup is something like this. You will have your server-side language from which you can generate a schema from the types that you have on the server side, and then you can query our GraphQL API, and you can build up the schema client side, and finally you can build out your SDK client side as well using these types. So we're communicating two things: we communicate data and we communicate types. This works by introspection. So, for instance, taking the query from before, we can now add the introspection type name field to this, and this allows us to return the type that is currently being returned. Right. So this is an example. We are fetching the root query type, and then the users. Right. Cool. Similarly, we can ask the API for the whole schema. We do that with the schema introspection field. In this case here, I'm just extracting the type names of every type that is defined in our schema. But you can basically extract the whole schema like this and build it up on your client side. And this is super powerful, and this is already built into the language. So going back to these three axes here, performance and developer experience and maintainability, how would this usually look for a REST setup, right? You will have, you can argue that in a performance axis, you have, REST is a super well-established technology. You have a way of doing very performant API, very good caching methods and so on. And you have other methods to, for instance, reduce the number of requests you're sending by just sending a bit more data each time. So that's sort of a solved problem. On the developer experience, you are able to generate SDKs in a lot of cases with technologies such as the Open API. And you can do that client side, and that sort of gives you whatever you would expect from good developer experience in that end. Finally, on the maintainability axis, I will say for most apps you only need one or maybe a few SDKs because you only communicate with one or a few APIs. You can define this globally. It doesn't change of where you are in the tree. So maintaining this is quite easy. You just update it one place, and then it propagates throughout out through your app. So doing a quick comparison of GraphQL and REST here. So GraphQL, we have this built-in type support that I've mentioned. The type system was sort of a core component of GraphQL. With REST, you have OpenAPI and so on, which is more like an afterthought. That means that you have a lot of use cases which, at least in my experience, have been very hard to communicate with OpenAPI, and at many points they are simply falling through. Right? You can fetch only what you need. You can select which fields you need, so you can limit overfetching. In GraphQL, you have some APIs which allows you to fetch only like a subset of fields, but generally this is the exception rather than the norm in my experience. You can fetch everything you need. It's like you can traverse down the dependencies of these types, and that limits the number of requests you're sending. Comparing that to REST, you probably need to send a few requests to sort of get the detailed objects and so on and so on. On the downside, I would say, on the downside, GraphQL's requests are not easily cacheable, if at all. This is in stark contrast to REST, where you most often can cache all GET requests, right? There's also a very steep learning curve in my experience. This is a new technology compared to REST, which has decades on its back and has very well-established patterns. GraphQL, not so much. So getting your whole developer team sort of on board in this might take significant effort. Finally, I would also argue that if you want to really use GraphQL, your API developers need to be API developers as well. You need to be able to for you to get the fully out of it, you need to be able to express the connections that you want between objects in your API, and then you can sort of implement it on the app side. With REST, this is different. You're often working on very on some objects, and they can be similar for all your apps, right? Right. So, regarding scalability, we can actually argue that you can use GraphQL as a drop-in replacement to REST, right? So every benefit you have from REST, you can use You can just rub in GraphQL, and that's fine. Of course, you have a steeper learning curve and so on. But it works all the same network protocols. You can build out your SDK around the mutation and queries like you would get and put and whatever. You can define some global data objects and then perform some error mapping to your HTTP error codes from GraphQL errors. Yay! Thank you, creepy AI-generated child. No, of course, that's not the point here. So I think if you do go down that route, if you use GraphQL as REST, you're missing out on two of the key benefits of GraphQL. You're going to be subject to overfetching because you don't have any easy way to do some field selection here. You're also probably going to be sending too many requests, as I argued before. So yeah, that's a lost opportunity, to be honest. Okay, so how do we do this? How do we limit overfetching? How do we limit the number of network requests we're sending? How do we support a great developer experience and while we're building reusable and maintainable widgets, right? This is what this presentation is about, so let's get to it. Let's take this very beautiful app that I've designed as an example. This app allows us to fetch some Star Wars movies and some associated metadata. We have split this up into 3 widgets. One widget, which is list itself, fetching the movies, and then you have a child widget, which is fetching the individual movies, and then we have the blue box component, which is a component rendering a character in that movie with name and birth year. So in that way, we have sort of split up our app by responsibility. It's probably quite maintainable and readable and so on. Right. Fetching the data to render this app can be done with a query like this, assuming some imaginary API that returns the right data. So you're able to fetch the films, fetch the title and episode ID, fetch the characters of each film, and then fetch the name and birth year for each character. And yeah, you'll see the data over here. You have films, which is an array, and you have the characters, which is also an array of character information. All right, using it in a widget could look something like this. In this example, I'm using Flutter hooks. Please just insert whatever fancy way you have of handling this kind of stuff. Block pattern, sure, that will work. But in this example, in this presentation, I'm going to use Flutter hooks because I think they're kind of neat. So in this case here, we are querying the query on the left. We're returning a column with a mapping the films to movie widgets, and vice versa, and etc. I mean, right. So where are we now? We're rendering our app. That's a great start for an app. We have built 3 simple widgets, and these and we're not overfetching anything. We're only fetching the data we need. Right. That's great. Now I would argue that our widgets are not at all easily reusable. Like, how do we get what data is used to render this widget? If we want to reuse it somewhere else, we need to go in, update our query, add the movie fields, add the characters, and so on. And that's sort of a burden. Now imagine that you want to add another field to this movie widget. You want to render more data or less data. How do you go about doing this? You remove it from your widget, and then you need to go back and again look at every query and sort of and update that. So our approach is not scalable with respect to maintainability. That's me. Still creepy. All right. So we can sort of refactor our code here. Instead of fetching everything with one query, we can split it up. Let's do like 1 query per widget. This way, we are able to easily define what data we need to render this widget, and we can just pass an ID down to the child widgets. I think that's a fair way to make something reusable. Just make it depend on an ID, right? This is what we're doing here. We have split up our query into 2, I guess 3 queries if there was enough room, right? One is fetching all the movies as before, and now one that's fetching a given movie by an ID. So we have the same query, whatever, and now instead of mapping the whole data down, we're just passing down the ID. Simple stuff. Right. So this iteration is rendering our app, which we want. We have built these 3 simple widgets still. Great start. We're not overfetching anything. We're only fetching the data we actually need to render our app, more or less. Like we are fetching IDs, but I mean, who cares? Our widgets are now reusable and maintainable. It clearly defines what data it needs to render, and we can sort of move it around. Now, arguably, this is not at all scalable with respect to performance. We are sending 3 layers of requests, basically. One layer which is fetching the movie list. So first, what's going to happen here? You're going to render the movie list widget. You're going to fetch the data. When the data is fetched, you're going to start rendering the movie widgets themselves, which in turn start fetching their data. And then at some point, you're going to fetch the character. So this is the waterfall effect, and this is not scalable. Wait. This is also me. Okay. So let me introduce you a language feature of GraphQL called fragments. Right. If you take a look at this query we have, we can easily see how we can split this query up into different fields that are relevant for different widgets. Right. So we have the film fields, which is the red box around, and we have the purple, pinkish box, which are going to fetch the fields that are necessary to render the movie widget. And finally, in the blue box, we have the fields necessary to render the character widget. Cool. Fragments is a way for us to then define fragments of our operations on our queries. So this fragments works by defining a part of the selection set, right? I'll come into that. So rewriting our query from before, we can rewrite it as 1 query and 2 fragments. Crazy. So what we are left with now is a situation where if we need to update the information that our movie widget or our character widget is going to render, we can just change the fragment, and we know that this is going to be propagated out to all our queries. Cool. We are rendering our app. We have built 3 simple widgets. Great start. We are not overfetching anything. We're only fetching the fields that we need. Our widgets are reusable and maintainable. And we have 1 request, so performant as well. Great start. Now, we are not at all utilizing the Dart type system, which is a shame. So this means that our code here is going to be very prone to developer errors, right? We're passing down a map from string to dynamic. We don't have any idea if this is null or not. We don't have any idea of the shape of whatever we're pulling out of this field, or this data object. And you know, we're bound to make mistakes here. I'll also say that our developer experience sucks because we have no kind of like field resolution or anything. If you update the fields, we're not going to be warned in our. If you update the selection set, we're not going to be warned in our IDE or anything like that. Now I will argue that our approach is not scalable from a developer experience perspective here. Yeah. Sad. Cool. So how do we usually solve problems like this in Dart, right? We do this with code generation. And I think we need 2 things here to get a great developer experience. First of all, we need to have serializers from our data. Like we have this whole query language which is all typed up. We can fetch the schema. We can reconstruct serializers on our client side. This should not be a problem at all. We also want the ability to, part of these serializers should be the ability to make sure that we're passing the right data down to our child widgets. Take this example here. We have now, we're now passing down we're now making the movie components now dependent on the fragment serializer, as you would see, instead of the dynamic data map, whatever. That's sort of a feature we want to have as well. These serializers are going to give us better IDE support, field resolution, null safety, whatever, the whole thing. Another point I think we need is generated SDKs and library methods, which is going to effectively sync up our queries with our serializers. Having serializers is all fine, but we're still exposing ourselves to mismatching of serializers, and at some point that's going to go wrong. If we take a look at the existing tooling out there, we have in the GraphQL environment, we have the GraphQL Flutter project, of which I'm a maintainer on top. And then we have on the shared second place in popularity at least, the Fairy and the Artemis frameworks. The GraphQL Flutter framework has no kind of code generation at all. And this also trivializes the ability to pass data down to the child components, the giant widgets, sorry. It does have advanced fragment support, which means that it supports fragments on unions and interfaces and whatnot, and contrary to the other two. Fairy, for instance, doesn't support passing down the serializers in a manner that I described before. And they also have some lackings when it comes to advanced fragments on the interfaces and unions and so on. Artemis, sort of the same. They have better serializers generated, but they don't have a great advanced fragment support. I mean, on the advanced fragment support, it's probably going to be fine for 99% of the use cases, but at some point it's not, and then you need to rewrite everything or just YOLO it, I guess. So, GraphQL CodeGen, written by me. This is basically a framework that extends and builds upon the GraphQL and GraphQL Flutter tools. It's generating serializers, it's generating client extensions for the GraphQL clients, it's generating hooks, and it has advanced fragment support. And all this is built on Build Runner as well. Everyone with us? Yeah? Great. All right, running the Build Runner with GraphQL CodeGen enabled is going to give us something like this. So you can see, this is from our example before, we have defined the movie list, movie and character widgets in each start file, and then we have the associated GraphQL files, which are all defining our fragments as we showed before. Then the generator basically generates a Dart file associated with this GraphQL file, which contains all serialized and whatever we have we need to generate. Right. So the way it works with generating serializers is that the code generator generates a serializer for each selection set. And the selection set is everything that's in the curly brackets. So this is basically a selection of field selections and fragment spreads and inline fragment spreads. In this concrete example here, we're generating 3 serializers, one for the query itself, and then one for each fragment. Now this, if you take a look at the generated serializer for the query itself, it will have a films property, and this will in itself be an array of these fragment movies. And this setup allows us to accomplish what we were set out for here. We can query our data in the parent widget, and then we can pass down the fragments seamlessly and make sure that the widgets are depending on the fragments and not anything else. Great, yay. It also supports multiple fragment spreads per selection set. So now assume that you want to split up your movie widget. It's becoming too bloated. And instead of rendering just one movie widget per entry, you want to render 2, right? You want to split up with the title in the top one, and then like metadata, characters, whatever, we don't care, in the bottom one. So in this case, we are going to generate 4 serializers instead of 3. We have one for the query. We have the 2 fragment serializers for the fragments. And then we are going to have a sort of a gathering serializer that is that implements the two fragment interfaces. And this setup again allows us to achieve the same thing that we want. It allows us to pass down our serializers into the widgets. We can pass down the same data into two widgets, and they will both get what they're expecting. Nice, yeah, cool. All right. So with serializers, we are less prone to runtime errors. We have null safety all the way from the backend into our app, and we have field resolution IDE and whatever, and everything is really standy on that end. Well, of course, we can be better. As we mentioned, we have whole other aspect we want to look at. How can we make sure that we are not decoupling the serializers from the SDKs or from SDKs or whatever. So we support two clients with GraphQL CodeGen. If you enable the GraphQL client, you're going to get generated these hooks. So this hook is this extension method on the GraphQL client itself, which is a super powerful feature. You can then just on the same client call query $fetch movies, and it's going to link up with the right serializers and everything. And that's how this works. Similarly, it's going to extend your client with some cache methods that allows you to write new fragments or read fragments from your cache. All of that just extension methods. And this achieves what we want, links together our client with our serializers. Cool. Good time. For enabling the GraphQL Flutter, we are then generating different hooks for each query. So in this example, we will have generated the use query $fetch movies hook, which again achieves the same thing. You can just put this in your build method, and you're going to get out the data you want, and everything's great. All right, let's go through the list. We're rendering our app. Great start. We have built 3 simple widgets. We are not overfetching anything. We're only fetching the fields that we need. We have only one request for our whole widget, and we are utilizing the Dart type system, right? We are less prone to runtime errors. We have better developer experience. And now I will say, like on these 3 axes we set out to, we are now in a scalable. Our approach is now scalable. And this is all of us, right? Great, yay, we did it. We've now built scalable apps with GraphQL. So, lastly, I want to get into the future of GraphQL CodeGen. So, what we're facing right now in the GraphQL and GraphQL Flutter libraries are that they are very general purpose, right? And that's good. That's how they were designed, and it supports all kinds of different patterns. You can use it with Blog. You could use it. You could use it as a drop-in replacement for REST if you want, or you can sort of work with the same structure I've proposed here, where you co-locate your queries and your fragments with your widgets. So when you have a library like this, we find it very hard to optimize, right? But in every axis, like as soon as you start changing something, start to make some assumptions on usage for some users, it's probably going to affect some others, and that is a hard place to be as library developers, in my mind. So we're currently developing a new client. This is called GraphQL Switch. The working title, at least. You should switch to it. No. This is heavily inspired by Relay, and it's going to be a focused, no-frills kind of API that's going to address a lot of the pains that we're seeing from our users in in GraphQL Flutter. We've seen the problems with people not being able to set up networking properly, handling cache properly, and so on. And this we really aim to go out and sort of extract that away. We're going to make some clear assumptions on how you're going to use this framework. For instance, we're going to suggest you use this pattern that I've proposed in this talk. But then we'll be able to do some pretty powerful stuff as well. We can inline the GraphQL in your code, making it even more readable, remove the need for all these external GraphQL files. We can start supporting refetching of individual fragments, for instance. We're going to have better pagination support, which is a huge issue for a lot of our users. And we can do like conditional rendering of some of these fragments as well. Yeah, that's what's suggested here. We are very early stage in this. This is not production ready at all. I started implementing mutations yesterday. Right now we support queries, and error handling is practically non-existent. This is just to say like this is where we're going, and maybe it's a good time to have some influence over how this will look. Just so you know. Right. This is an example of how it could look like. Follows a lot of the same structure I've already shown you. The largest difference here is that you are inlining your GraphQL directly into your code, make it more maintainable, making it easier for you to see which fields you're actually using in your widget and removing them. And similarly, in that notion, we are introducing a use fragment hook, which allows you to do the same thing. Again, very inspired by Relay, so if you're familiar with that, this should not come as any surprise. So, if this relating both to GraphQL Switch and GraphQL Flutter, of course, if you want to help out, we're always very happy to accept pull requests on both projects. If the developers or if you're a documentation engineer, that would be very nice, because this is always something that we are down prioritizing. I think it's become very apparent from our community that we could do with better documentation, and like if anyone has experience with that and wants to join in, that would be amazing. Of course, early adopters is great. We are making some bold claims around performance and so on. So we would love to have your experience with that and help us move this libraries in a good direction. This is how you can contact me. This is where you can create issues on our GitHub. And if you need any support with any of this, we have a very vibrant community on Discord with a support channel where we are usually replying within hours to people's requests, regardless of what level it is, and trying to fix people's bugs. Right? That was it. Good ahead of time, but that's how it is.